Hello class, good day. Ayan. So I am so sorry because we don't have any stable internet connection yet in our city. So as an alternative solution for you to have an online discussion is to have it asynchronous. So I have here my recordings for my topic for week 5 all about the introduction of exponential function. So from the word itself, exponential functions, what is the root word of the word exponential? Correct. The correct answer is exponents. And I guess that you already learned the exponents or the concept of exponents when you were in grade 7 or in grade 8. As well as grade 9 actually. Actually, that's the, that's the very foundation of exponent. I guess when you were in elementary, because I was teaching grade 7, grade 6, I already taught them that that we have here exponentials or exponents rather. So ayun. So what is exponential functions? Later we will discuss. So first of all, let us first have a view on what we have on your elementary days, on your junior high school days in mathematics. So I have here an exponential function or an exponential equation. So I have here y is equal to 2x. So all we know that we have an exponent here. But which is the exponent? So let's have first a review that if we have an exponent, there also exists its base. Because an exponent does not exist if it hasn't have a base. So in the expression 2 raised to x, the x there is the exponent and the base there is 2. So we have 2 raised to x. So what number that is raised, or actually when you encode the number, it's superscript. When we say superscript, we put the, any number or any letter above slightly from the number beside it. So we have here a superscript of x, and that is our exponent. And then the number wherein actually the exponent is anchored. That's what we are trying to to explain with mathematics when we have exponent. So the exponent is actually anchored to its base. Okay, so 2 raised to x, 2 as the base and x as the exponent. It's basic actually, you know this. So what does it mean if a number has an exponent? The number is multiplied several times equivalent to the exponent to itself. Basically, if we have the base and it has an exponent, we need to multiply the base several times equivalent to its exponent to itself. So, if we have 2 raised to 4, the answer probably is not 8. Okay? So, when we say 2 raised to 4, it means that we have to multiply 2 4 times, or quadruple. So we have 2 times 2 times 2 times 2. That leads us to the answer of 16. Okay, so this is the very, very important concept in exponent. Because sadly, there are some students who have it, just simply multiply the exponent with the base, which is actually incorrect. Instead, you need to multiply the, the base several times. That is actually equivalent to its exponent. So since we already reviewed the exponents, now we have here the exponential equation, exponential inequality, and exponential functions. Actually, I'm not familiar with the junior high school curriculum if you already discussed these topics, especially the equation and inequality. But I guess if this is the first time you are about to encounter exponential equation, inequality, or exponential function, therefore it's the perfect time for you to understand and to listen. Okay? So I have here my definition and my example of exponential equation, exponential inequality, and exponential function. So let us first distinguish the distinctions or the differences of these two, or sorry, among the three rather, I'm sorry. So I have here exponential equation. So an exponential equation is an equation involving exponential expressions. So how do we define exponential expressions? So as you can see here, class, we have here 7 raised to 2x minus x squared is equal to 1 over 343. What can you notice with our exponents? So I'll highlight all the exponents. What can you notice with our exponents? Very good. Actually, why I'm talking to myself when I am about to have this asynchronously, diba? So again, so as you can see, we have variables in our exponent. And that is actually the point of exponential expressions. We cannot have we cannot have an expression, an exponential expression, if the variable is not present in the exponent. Okay, it's simply just an expression. Maybe it's rational, it's polynomial, or it's whatever. But if the exponent, sorry, if the exponent is contained in its, if the variable has if an exponent has a variable, maybe it's x or y or whatever variable that we can name or we can label with, therefore it's an exponential expression. And if it involves an equation, there's an equal sign there, it's an exponential equation. Okay? The clue there is the variable is present in our exponent. Okay? Next. Of course, you are familiar with exponential inequality because it only, it only shows an inequality. And of course, there is a variable in the exponent. So aside from, we have here less than or equal. So aside from less than or equal, we have other signs that shows or that expresses inequality, such as greater than, less than, we have greater than or equal to. Of course, in example, we have the less than and equal to, and of course, we have not equal. So that are the symbols or the inequality symbols that is used in an exponential inequality. And of course, we have exponential function. If the output is expressed in the function of x or an input, therefore it's an exponential function. So we have here f of x is equal to 1.8 raised to x, or y is equal to 1.8 raised to x. So either of the f of x or the y could be used as an exponential function. Okay? Okay. Okay. Who's the imposter? So which of the following is an exponential function, an exponential inequality, an exponential equation, or none of these? So I have here 10 items, and if I were you, I am about to pause this part of the video and answer which of these 10 items is an exponential function, an exponential inequality, an exponential equation, or none of these are exponential, something. Anyway, so you may pause this because for a while we will be determining who is really the imposter.
few moments later.
Okay, so now we will be determining the answers. Okay, so number 1, we have f of x is equal to 5x raised to 2. So this is none of them. Why? Because our first thing that we should look in our equation or our inequality or in our function is that there would be a variable in the exponent. For that item or for that equation to be called an exponential function, an exponential inequality, or an exponential equation. Okay, so number 2. Number 2, of course, since it's used an inequality symbol, therefore it is an exponential inequality. Number 3. Number 3 used y. So y, it can be an exponential equation. But since it uses y, which is the function or the equation is a function of x, so this is an exponential function. Next, we have 4 times 10 raised to x minus 2 equals 500. Correct. That is an exponential equation. How about this one? 7 is greater than 14 raised to pi plus 3. Remember that our pi has a value 3.1416 and so and so. Therefore, pi there is an irrational number and pi is not a variable. So, number 5 is none of them or none of these. Number 6, y is equal to 0.5 raised to x or 0.5 raised to x. This is an exponential function. Why? Y is in the function, or y is a function of input or of x. Number 7, of course, it's an exponential inequality. Number 8, it's an exponential function, just like number 6. Number 9 is none of these. Am I right? Yes, there's no exponent there. And number 10, it's none of these also, because there is no variable in our exponent. Now, what score did you get from our activity? You get 7, 8, 9, 10? Well, you're very good. You learn, or you actually learn from our video. But if you get 0 to 6, which is actually unfortunate, you may have our video again to watch so that you may learn more. Okay? Or you may try more examples. Or you may even try to answer this activity again. Now, where do we apply exponential functions? So, exponential functions has many applications in our real-life situation, such as finding the formula or the population growth, which is actually, we are actually doing that in the statistics office or in our census. We have also the half-life. We actually do this in science, right? So if we have experiment and we are trying to to know to know the age of a certain object that is from the past or from the history or an artifact, correct? We need to have it in half-life. And of course, we have compound interest. Additional, for the population growth, we can also determine the population of a certain bacteria as it grows from time to time. So this encompasses our 3 strands. So the Humes can use the population growth in their census, in social work, or even in population in social studies. Half-life can be, by the way, population growth can be also used by STEM students because they know how to, to culture bacteria and so, or even the people, how does a people grow in such time, or even business people because they are trying to know the demand and supply using population growth, right? Half-life can be used by STEM students because it's actually more on, scientific studies, while compound interest is actually studied by the ABM students. So exponential functions is very, very timely on your strand. Anyway. So, in mathematics, we cannot able to apply just to, to just knowing what's its application, but trying them. So, we have here problem solving. So, in problem solving, we have here a certain format, and we use Pauli's four-step rule on problem solving. So, who is the proponent of the Pauli's four-step rule on problem solving? Correct. So we have here a possessive, the name is under its possessive something, diba, in English. You know that if there's an apostrophe and there's an S, therefore that thing is possessed by someone. Okay? So I have here George Polya. George Polya was an Hungarian who is immigrated to the U.S. state. So he is a U.S.-Hungarian citizen. So in 1940, his major contribution of his work in problem solving is to create a four-step rule that would really help someone or everyone to solve easier with understanding. So Polya created this famous four-step process on problem solving, which is very useful, as I've said a while ago, for our problem solving in our discussion. So what is the four-step rule on problem solving? Step 1, explore. Understand the problem. So I have your question. Have you ever been asked by someone in your place with, "Agalimik ka iko yun?" And you can't answer the question because you don't speak or you don't really understand Korean. Actually, it is actually, the meaning of that phrase is actually, can you understand Korean? That is why this step wants to, this is what this step wants to emphasize, that to get the desired results, you need first to understand what is asked, or what. To get the desired results, we need to understand what is asked for us to find. We need first to understand the very, very complexities of the problem for us to solve, or even every information given in the problem. We should have a full understanding on what we should do, right? Even actually in our daily basis problems. So it is very important to comprehend the problem very, very, very well. That is for step 1, explore and understand the problem. For step 2, we need to have a plan. We need to devise a plan or to translate. Of course, when we create a plan, we should know what to do and what materials we need to accomplish our goals. In mathematics, we should know what formulas or algorithms to be used in doing your plan, and the given should be labeled correctly. So you need to have a procedure. You need to have a formula. You need to have all the ingredients or all the given for you to be solved, right? So that is in our plan. We need to devise a plan, and we need to get the perfect things to our plan. Next, solve. This is actually, the term we actually use here is execute. So step 3, solve. Carry out your plan. Since you already understood the problem and you have your plan and all of the things you need to do, it is now your time to solve or to execute your plan you have created in step 2. Any answer you obtain is the result of your planning and your execution. And of course, on the way how you understand the problem. And number 4, check. You need to look back. This is actually the step that we actually skip because we are contented on what we got, but actually it's a no-no. It's a big no-no in mathematics and even in our daily basis. Why? Because, as I've said in this quotation, ang hindi lumingon sa pinanggalingan ay hindi nakararating sa paroroonan. Indeed, we should look back to where we have started. In mathematics, we should counter-check if our answers are correct by tracing our solutions from the very, very beginning. So, in this step, check all the steps regardless whether you have got the correct answers or not. So, in this step, Check all the steps regardless whether you got the correct answer or not. By doing so, you may secure that your answers are correct. Or, if you got the wrong answer, you will learn in which part of the problem you committed a mistake. You should know how to interpret your answers, of course, by looking in the main problem. So, in here, not only to check what is right or what is wrong, or go back to the processes, it's actually how to interpret your result. Because sometimes it's not only on the given result. You need to interpret more, or you need to have a conclusion for you to really understand the answer and to get the main core of the solution that you need, or the answer that you need. So let us first review, explore what is asked. So what are the needed data? These are the guide questions that we have. Step 2, plan. What is the formula to be used? What are the given? Step 3, solve. What is your solution? And step 4, check. What is the answer? So, are you ready? Let us solve the first topic, or the first real-life example. We have the population growth. Suppose a quantity y multiplies by n times every t units of time. If y sub o is the initial amount, then the quantity y after t units of time is given by y is equal to y sub 0 times n raised to capital letter T over small letter t. Sir, ano pa ibig sabihin nito? Hindi mo maintindihan. So, kunwari, binigyan kayo ng object. Dumadami siya or nagmumultiply siya by ilang beses, by n times, every t unit, small units. Ngayon, pag binigyan ka pa ng iba pang time, binigyan ka gaano kaya katagal, gaano kaya karami kapag ganito yung tinagal. Yung ganito katagal, yun yung capital letter T. Okay? Yung small letter T, yun yung rate. Okay? Nag-get siya ba? Ganito yung dami ng object kapag ganito yung ano niya, yung dami. Ganon. So, yun siya. So, yun po. We have the formula. Now, of course, let's try. At t equals 0, there will be we have an example here. At t equals 0, there were initially 20 bacteria. Suppose that the bacteria doubles every 20 hours. So A, give the exponential model / function of the bacteria as the function of t, and B, find how many bacteria are present in the experiment after 60 hours. So, let's begin. So we will be doing the Polya's 4-step rule of problem or on problem solving. Now, we will be using the Polya's 4-step rule on problem solving in answering this problem. So, okay. So, first step is, what's the first step again? The first step is step 1. We have the what? Very good. We need to explore. So, what's the question under explore? What is asked? So, what is asked? So, we have 2. We need to have what? We need to have the exponential model. And number 2, how many bacteria are present? So, we have B. So, you need to copy here. How many bacteria are present, and so and so. Class, all you need to do is to copy the question there. Or if there is no question, you try to create the question out of the problem. Since it's actually spacious if I'm going to write all the things here, so you may continue this, okay? But, again, you need to have it full-blown question there, okay? Dapat yung buo. Wag na yung shortcut. Ako lang yung mag-shortcut muna ngayon kasi, ayun nga, di kasha. Okay. So, ano yung mga given data? Okay. So, siguro, diretso na tayo sa step 2. So, step 2, ano yung step 2? Okay, plan. Plan, right? So, we need to have a plan. So, let's get all the given. So, ano yung mga given? So, at t equals 0, there were initially 20 bacteria. So, we have here y is equal to 0. right? So the given is 20, right? Because it's the initial population, right? And then the suppose the bacteria doubles every 20 hours. So our small letter t here is 20 hours because the bacteria doubles every n hours, right? So that would be, sorry, the n there is the 2. So we have n is equal to 2. And the t is doubles every 20 hours. So the bacteria doubles every when? Every 20 hours. So the question is, how many bacteria are present in the experiment after 60 hours? So that is the capital letter T there. That is 60. Okay. So that would be for our step 2. So in our step 2, there also the question, right? What is the formula being used, or what is the formula to be used? That would be the formula earlier. So we have y is equal to y sub 0, okay, times n raised to t, capital letter T, over small letter t. Okay? Next is to have it the next step. Step 3, we need to solve. So how to solve? Of course, all we need to do is to substitute the given to the formula. So we have y is equal to y sub 0 times n raised to t over small letter t, and then substitute. We have y is equal to what? 20 times our n is 2 raised to 60 over 20. That would become 20 times 2 raised to 3, because 60 divided 20 becomes 3, right? And then we have 2 raised to 3, we have 8, 20 times 8, that would become 160. So that would be our step 3. What is step 4? Step 4 is to interpret the answer. So, there are, what? There are 160, sorry, bacteria in the experiment. After 60 hours. So that is the answer. Okay, so in example number 2, you may pause this video for you to answer. Okay, so a certain town has 1,500 individuals, and its population triples every 100 years. What would be the predicted population of the town after 3 centuries? So, again, we will be using the Pauli's 4-step rule and problem solving. So, okay, so we have step 1. Step 1 is explore. So what is asked? Okay, so what is asked? So maybe I'll just highlight what is asked here. So this is the question. What will be the predicted population of the town after 3 centuries? So that would be for our step 1. Sorry. For step 2, last you write it here, ha? Since I am saving space, because I'm writing in my slide, so it better you write that if you're writing in paper. But for me, yeah, I will have it shortcut, as I've said earlier. Okay, for step 2, you need to write all the given and the formula. So what are the given? So let us first find what is y sub 0. Y sub 0 is 1,500, right? That would be 1,500. And then, population triples every 100 years. So, n is 3 because it's triple. So, 3 multiplies by 3 times. Every when? Every 100 years. So, our small letter t would be 100. what would be the predicted population of the town after 3 centuries? Now, in our time, we have different units. We have years and centuries. So all we need to do is to convert maybe 3 centuries. Yeah, we convert centuries into years. So how many years are there in a century? Very good. That would be 100. So, if there are 100 years in one century, therefore, how many years are there in 3 centuries? Very good. That is 300. Okay. Now, since our units of time is similar, maybe we can start solving. But not yet because we haven't have our formula. So what's the formula again? Y is equal to y sub 0 times n raised to capital letter T minus, divide small letter t. You know, I write it correctly, but I said it wrong. Okay. For step 3, of course, all we have to do is to solve. So how to solve? Just simply substitute all the givens in our formula. So what's the formula again? Y is equal to y sub 0 times n raised to capital letter T over small letter t, or divide small letter t. Then simply substitute the given. Y sub 0 is 1,500 times n. What is n? 3. Raised to, what's t? 300 over 100. So that would be 1,500 times 3 raised to 3, because 300 divided 100 is 3. And then 1,500 is 3 raised to 3. So that's not 9, it's 27. Why? 3 times 3 times 3. So if you have difficulty in, in doing it manually with your mental brain as your calculator, mental calculator, or your brain as your calculator, you may have it in calculator. You may use calculator here, as long as you know the concept of doing the problem. Okay? So we have here 1,500 times 27. That would be 40,500. So, step 4, what's the complete answer? Because all we need to do is to, to interpret our answer. So, the predicted, actually the complete answer would be from the question actually. So, the predicted population, I have difficulty in writing, oh my god, of the town after 3 centuries is 40,500 individuals. Oh my god, there's no space. So that is how we do it on Polya's 4-step rule on problem solving. So, and that ends up with our example in our in our population growth. Our second example of the real-life applications of exponential function is all about half-life. If the half-life of a substance is t units of time and y sub 0 is the amount of the substance corresponding to t equals 0, or the initial amount of substance, then the amount y of substance remaining after t units of time is given by y is equal to y sub 0 times 1/2 raised to t over t. Capital letter T over small letter t. Are you familiar with the formula? This is actually similar with the population growth. Okay? But this is not a growth. This is the decay. If we have here earlier the exponential growth, actually class, the population growth is also called the exponential growth. Okay? The half-life is the best example of the exponential decay. Okay? Since kapag sa population growth kasi palaki na palaki, yun yung growth, kaya siya growth. Sa decay, pakonte ng pakonte. Okay? And one of the example is the half-life. By the way, we will be discussing that more in the next week. Okay? So same process. We will be doing the same process also. So we have here example number 3. Suppose that the half-life of a certain radioactive substance is 10 days and there are 10 grams initially. Determine the amount of substance remaining after 30 days. Okay, so again, there will be there will be non-stop Polius 4-step rule and problem solving in our discussion for today. So we have step 1, what is asked? What is asked again? What is the amount of substance remaining after 30 days? So that is our step number 1, what is asked. For step 2, what are the givens? I actually removed the given data in step 1 because all you have to do is to write it in step 2, but it's labeled correctly. So it's better to write it in step 2 na lang para you have it you have it clearly, right? Okay. So so the initial amount, the y sub 0 is the initial amount. So that would be 10 grams. So what's the t? What is the half-life? It's 10 days. Okay. So what is remaining? That's the capital letter T. So that would be 30 days. Okay. What else? Oh, there's no more given because half-life. It's half-life. So our n is 1/2. In half-life, n is always 1/2, okay? So the formula is y is equal to y sub 0 times 1/2 raised to capital letter T over small letter t. Sorry. For step 3, all we have to do is to substitute all the given to our formula, as we usually do in the problems earlier, right? So we have here y is equal to y sub 0 times 1/2 raised to t over t. What? It's capital letter T over small letter t. Okay, so that you are not confused, by the way. And then, substitute all the given. So we have 10 times 1/2 raised to 30 over 10. So we have 10 times 1/2. 30 divided 10 is 3. So what is 1/2 over 3? 1/2, okay, divided by 3. Sorry, it's not divided. So 1/2 raised to 3, that would be 1 over 8. So 10 times 1 over 8. So 10 times 1 over 8, that would become, okay, so the answer is what? 1.25. So I'll be writing it here na lang. So step 4, what's the complete answer? So the amount of substance remaining after 30 days is 1.25. What's the unit? Grams. Do not forget the unit, especially if it's given in the problem. Okay? So, I hope you can answer this example number 4. Again, you may pause the video and then later on you will try to check your answers. So now let's try to check your answers. Okay, so I have here, okay, the half-life of a radioactive substance is 2 days and there are 100 grams initially. Determine the amount of substance remaining after 2 weeks. Okay, so first, step 1, what is asked? Okay, it's actually similar. So determine the amount of substance remaining after 2 weeks, or what is the amount of substance remaining after 2 weeks. So that would be our step 1. Step 2, write all the given. So we have y sub 0 is equal to 100 grams. T is, what is the half-life? 2 days. So 2. So what's the capital letter T? Since it's given the 2 weeks, that's the capital letter T, but it's not actually the same unit as what we have on our small letter t, on our half-life. So we need to convert. How many days are there in a week? There is 7. So if we have 2 weeks, there would be 14 days. Very good. So for step number 3, as we have done earlier in our problems, just simply substitute all the given in our formula. So y is equal to y sub 0 times 1/2 raised to capital letter T over small letter t. That would be 100 times 1/2 raised to 14 over 2. That would be 100 times 1/2 raised to 7. Okay, simply multiply those numbers. So we have 1/2 raised to 7 times 100. That would gives us 0.78125. Or you may round your answers to the nearest 2-digit number or to the nearest hundredths. So that would be 0.78. Okay, so step 4 is the complete answer. The amount, oh my god, this is very stressful actually. The complete answer. The amount of substance remaining after 2 weeks is 0.78 grams. So imagine if you have what? If you have a food and the the half-life is 2 days, and then you left it you left it in an open space for 2 weeks, and then out from 100 grams it becomes 70.78 grams na lang. Diba? Ganon. Okay. So do you have questions? If you have questions, contact me in Messenger. Okay? Okay. Okay. So lastly, we have the compound interest. If a principal P is invested at an annual rate of R, compounded annually, semi-annually, quarterly, or monthly, then the amount the amount of P years is given by A is equal to P times 1 plus R raised to TC, wherein C is denoted by compounded if it's compounded by how much it is compounded. So if it's compounded annually, C would be 1. Compounded quarterly, C is 4. Compounded semi-annually, C is 2. And compounded monthly, C is 12. Because annually, when you divide 1 year by 1, that's 1. Quarterly, because there would be 4 quarters in a year, so that would be 4. Semi-annually, because there are 2 half years in a year, right? And we have 12 months in a year, so that would be 12. So you don't need to convert the time here because it's actually has a formula for that. And actually, class, compound interest is discussed on your business mathematics anyway. So for you to have an easier grasp on business mathematics in quarter 2, we need to discuss this. Okay, we have example number 5. Mrs. De La Cruz borrowed 100,000. Oh my god, I have corrections in 100,000. So this is 100,000, class. I'm so sorry for typographic errors. So yeah. So Mrs. De La Cruz borrowed 100,000 pesos in a company that offers 6% interest compounded semi-annually. How much will she pay in total after 3 years? Okay, so again, non-stop, Polias 4-step rule and problem solving. Step 1, what is step 1? What is the question? So, this is the question. This is the question. Here, you write it here. In those which are in highlight, you write it here for step 1. Okay, step 2. Step 2, write all the given. So what's the P? The principal amount. That would be how much is borrowed by Mrs. De La Cruz. That would be 100,000 pesos. What else? What is the rate? Rate is how much interest is given. So 6%, or in mathematics that would be it should be 0.001 0.06 or 6%. So time, how many years she need to pay the borrowed money? It's 3. Question, what is C? Compounded what? Compounded semi-annually. So how many semi-annuals or how many half years are there in a year? So there are 2. So what's the formula? The formula is A is equal to P times 1 plus R raised to TC. Okay, so step 3. Again, as we usually do in step 3, just simply substitute all the given in the formula. So we have A is equal to P times 1 plus R raised to TC. So we have 100,000 pesos times 1 plus, what's R? 0.06 times, what's P? 3 times C, which is 2. So we have here 100,000 times 1.06 times 6, right? Okay. Now, with the use of your calculator, of your scientific calculator, just simply type those values. So 1.06 raised to 6 times 100. So the answer is 141,851. So round it to the nearest 2-digit numbers or to the hundreds place, because this is money, remember? So that would represent our centavo. So 0.91. Okay, so step 4, we need to write our complete answer. So Mrs. De La Cruz will pay what? We need the peso sign because it's money, remember? 141,851 pesos and 91 centavos after 3 years. So class, in step 4, actually, it's up to you how to create your sentences. Anyway, it is learned in your English or ACAD, to how to answer, right? If you're given a question. I'm not sure. I'm so sorry. Mamela will beat me. Anyway, so it's up to you how to create or to construct your complete answer. As long as it is understandable. Not really perfect, not really grammatically correct, but it's understandable. Anyway, you were, correct. And the important there actually is the final answer and the unit. Okay? So that would be for our interest, for our compound interest. Now, you are allowed, or you have time, I will be giving you some time by pausing the video to answer this example. And this would be our last example for today. So don't be so bored if you were given this one. So you may pause the video. Okay, now, I hope you answer and you pause my video. So let's answer. So Eunice deposited 1,000 pesos in a bank that pays 5% quarterly compound interest. How much money will she save after 2 years? So using Polya's 4-step rule of problem solving, we will answer the problem. So step 1 actually is the question. How much money will she save after 2 years? So that's the question. Actually, this is not actually saving space, but actually we are, what's this? Yeah. We are just lazy in writing our because it's long. Yeah, it's long, kaya we need to save space then for our, important answers. Anyway, so step 2, what are they given? What is the principal amount? 1,000 pesos. Actually, class, it's pronounced as pesos in dictionary, but we Filipinos used to, you call it peso. So, peso. Okay, so let's correct ourselves. It's Philippine peso. Pesos. Okay. From now on, we will call that pesos. Okay. So the principal amount is 1,000 pesos, and the interest, the rate is 5%, and that would be equal to 0.05, right? So we have time. How much money will she save after 2 years? So that would be our T. And compound interest. Our interest is compounded quarterly. So how many quarters are there in 1 year? There would be 4. Okay, step 3. We need to substitute all the given in the formula. By the way, we forgot to write our formula in step number 2. So A, the amount is equal to P times 1 plus R raised to TC. So A is equal to P times 1 plus R raised to TC. So substitute, we have 1,000 pesos, 1,000 pesos plus 1 plus 0.05 raised to 2 times 4. So we have 1,000 times 1.05 raised to 8. So let's have this inputs in our calculator. So we have 1.05 raised to 8, because of course when you raise into larger number, it's really hard, right? Especially this is decimal, you know, times 1,000. Oh, so I hope we got the same answer. It's 1,477. Round it up to the nearest 2 decimal places. That would be 455. So it's 4 to 6. So step 4, final answer. Eunice will save how much? 1,477.46 pesos after 2 years. Okay, so that is our answer. And that concludes our topic about the introduction of exponential functions. If you see some errors in my discussion, feel free to comment in this YouTube link. And if you have questions or queries or anything that you didn't understand with our discussion, please kindly have me the message in our group chat in Messenger. Okay, because we are actually having a difficult time in in discussing these things in this current situation that we have pandemic, and we always rely on the internet for us to learn. Actually, our school is lucky because we are allowed to have or to conduct online classes, and we are really privileged because some schools, they don't have this thing. So you are you are blessed. We are lucky because we honed more advantageous students because we have online classes. And maybe, I don't wish, but maybe we don't know that pandemic will runs until you will graduate in college or even you graduate in high school. So at least when you go to college, you are prepared because you get used of our classes with our online classes. Okay, so thank you for those who watch. I hope you learn with this simple video. Thank you very much, and God bless to everyone. Bye.